Hello, everyone. I'm Nate Truex, and you're listening to the Croccast podcast. Hello, everyone. Welcome to the Croccast podcast. I'm your host, Nate, and today I'm joined by Dr. Steve Salisbury of the University of Queensland. Steve, welcome to the show.
Hey, g'day. How you doing?
I'm doing well. So you want to get us started off on how you first got into, well, I should specify you're a paleontologist, so I should ask how you first got into paleontology and what led you to studying uh, extinct reptiles.
Well, I guess as a kid, like a lot of kids, I was pretty into dinosaurs, loved rocks. So paleontology was always going to be a thing. I didn't really know exactly how I was going to get into it while I was at university. I did my undergrad at the University of Sydney, did a double major in geology and zoology, and we did a bit of paleontology there. I did a bit of anatomy and stuff, but it wasn't really till postgrad that I was able to get into it. And at that time, pretty much the only lab that was actively doing paleontology stuff was Mike Archer's lab at the University of New South Wales. And Mike had I was probably about 4 or 5 PhD students that had been kind of given the first sort of good batch of material that had come out of Riversley in North Queensland. So I went and saw Mike and, asked what was going on with regard to projects and things. And, pretty much he'd heard the interested in dinosaurs thing many times. And he sort of said, there's not really any Australian dinosaur stuff to work on at the moment, but if you're interested in crocs, I can introduce you to Paul Willis. So Paul had was kind of getting towards the end of his PhD on Riversley crocodilians. So he had worked through a lot of Riversley stuff there, but in the process, it also looked at various other Australian Cenozoic croc fossils. And this was sort of mid-90s, and around that time, Mike Archer's team and Hank Godthelp and a few other people had been starting to work on material from a fossil site in southeast Queensland on Waka Waka country called Mergen. And Mergen is sort of lower Eocene in age, so about 55 million years old. And Paul had just described a new fossil crocodilian from Mergen, Canberra mergenensis. And there was a beautiful skull of Canberra. But Paul had sort of said, there's something weird going on at Mergen. There seems to be a lot of variation in all the fossil croc stuff. Do you want to try and figure it out? So that sounded like a good sort of option for me at that point. And that was really my entrance into the world of crocodilians, fossil and living. And I mean, we're fortunate in Australia, I guess, kind of like the US, in that we've still got living crocodilians here. So there's a lot of good material in museums that you can examine, and if you want, you can also go and watch live ones doing their things. Yeah, so I started working on all the various bits and pieces of fossil crocodilian material from Mergen, and I volunteered to start to do fossil prep work in the lab, and was able to go on a field trip up to Mergen, and I can't remember exactly how it happened. It's a while ago now, but I think either during that field trip or the one prior to it, another skull had been recovered, and I sort of took over preparation of this new skull. And as I was doing that and looking at all the stuff that was in the Mergen collection, and there was quite a lot of croc material from Mergen. A lot of it sort of disarticulated, and it wasn't really clear how it was all associated. But it very much looked like there was, as Paul has suspected, more than one species there. And when this new skull, when I finally managed to get it out, it was a beautiful, nearly complete skull. It was indeed similar, but notably different to the skull that Paul had described as Canberra merganensis. So I was really lucky, I look back on it now to be given essentially a nearly complete early Eocene croc skull from Australia to work on for my honours. And we're able to write it up and describe it as a second species of Canberra. And it was a really good project for me because I had to kind of address, what is a fossil species? How do we sort of recognize fossil species in the fossil record from fragmentary material? And I spent a lot of time looking at collections of both Indo-Pacific crocodiles, so Crocodilus porosus and Crocodilus johnsoni, the Australian freshwater croc, in museum collections around Australia, and began to kind of get a good handle on just how variable they were, because obviously there's quite a lot of size variation, and then there's all sorts of weird maturity related variation that seems to happen depending on diet and behavior and stress and all sorts of things. So that was really good. And it kind of, got me really interested in the whole fossil croc thing. It got me into taphonomy, understanding sort of how fossils sort of come to get preserved and what it can kind of tell you potentially about the paleoecology of crocs. And yeah, really sort of set me up for wanting to do a PhD on something related to crocodiles. That was really the start of what would sort of really take me all around a journey all around the world, sort of addressing all sorts of interesting questions around crocs.
Yeah. Now you're kind of lucky in Australia in that your fossil record for crocodilians has a group that's found nowhere else in the world, right?
Yeah, so we've and the material that I described, I mean, at that point, we were only just starting to figure this out. So it was only, a few years prior to the description of Canberra merganensis by Paul Willis that he'd proposed, along with Ralph Molnar, that there was this, potentially endemic radiation of crocodiloid crocs, so things related to living crocodilians, but potentially a separate family or subfamily, which initially, the first sort of member of this group of crocs that had been recognised was one from New Caledonia, Mekosuchidae inexpectatus, and that, along with some of the Riversley crocs that Paul had been working on, that were sort of around 23 to about 16 million years old, some a bit younger, plus the Mergen stuff, became the basis of the creation of this new clade that took on the name of Mekosuchidae. And initially, I think Eric Buffetot and colleagues had proposed a distinct family for Mekosuchidae inexpectatus as the Mekosuchidae, but Paul and Ralph thought a subfamily was a more appropriate level. So it was from that point on that this radiation, Cenozoic radiation of Australian crocs, became known as the Mekosuchines. And yes, that was really fun to be sort of, at the forefront of beginning to understand this unique, potentially unique radiation of crocs that persisted in Australia for, over 50 million years. And I think with the description of the second species of Canberra that I did for my honours, Canberra and Plexidens. That was the first kind of serious attempt at doing, at the time, what we considered to be a fairly comprehensive phylogenetic analysis of all these crocs, and sort of including a lot of taxa from other parts of the world, and beginning to really kind of create a phylogenetic framework around where they fitted, and then from that start to sort of propose sort of ideas as to where they came from and how they got here and how they related to other crocs and stuff. So it was exciting back then.
Yeah, speaking of where they came from, how they got there, that was actually my next question. I have only a rough understanding of the Mekosuchidae. So if I remember correctly, their earliest fossils from the Paleocene, early Eocene?
Yeah, so the earliest sort of confirmed ones are the ones from Mergen, so Canberra, and there's a third species, or there's 4 species of Canberra actually. There are 2 from Gladstone that are about the same age. Yeah, so sort of early Eocene, maybe a bit older, but some of the ages around that material is a bit debatable. So about, let's say like 55 million years ago, up until probably, around 100,000, maybe more, the sort of ages for confirmed Mekosuchon material start to get a bit sketchy as you get closer to the end of the Cenozoic. So, they've got a good 55 million year record in Australia. And I mean, there's some puzzling things going on. Like at the beginning, it's just this idea of, it's just this Australian radiation, and, it all sort of seemed like a great idea, but there were always a few taxa in there that didn't kind of fit the pattern. So, we had a taxon from Bullet Creek called Harpacocamsa, this sort of narrow snouted thing that initially looked a little bit like a gharial, that didn't, in our big analysis back then, didn't seem to be a Mekosuchide, seemed to be, maybe closer to Mystoma or something. So that was there. And then there are a bunch of other things that, it's like, what's going on here? Like, and I think it's still feel, since then, we've obviously done a lot of work, and I've had students work on it and stuff, and we've tried to refine ideas around things. But one of the mysteries that has persisted is, if it is this uniquely Australian radiation, when did it get here, and from where? So back when I started, like, it was not clear at all, because the standard kind of pattern had been, the one that a lot of groups, including marsupials, seem to have followed, which was arriving in Australia from other parts of Gondwana, coming primarily through South America, presumably through Antarctica, and into Australia before it broke away from Antarctica around 40 million years ago. So, you'd think maybe that was a good model for what had happened with Mekosuchides. So just, like other taxa had followed the same path. The thing was, there's never been anything in South America or Antarctica that looks like a Mekosuchide. There's barely any kind of evidence of crocodiloids at all in the Cenozoic, early Cenozoic of South America. There are a few, potential things, but they're so scrappy that, and they've always ended up being sort of alligatoroid or something, that it's never made any sense. So that's never seemed like a good option, even though it seems like pretty much the only way in, because the other way in is through Southeast Asia. But at that time, Australia is still quite a distance from Southeast Asia. We're much higher latitudes. So even though crocs can swim, well. You know, they can cover vast distances and get across marine barriers that other animals can't. It still didn't seem plausible that they'd somehow, you know, traverse this massive distance from, you know, the what would eventually become all of Southeast Asia today and sort of arrived in Northern Australia. It just didn't seem to work. And then as well, you know, there wasn't really anything in Southeast Asia that looked like a closely related Mekosuchidae taxon. So it's always been a bit puzzling. I've always found it tricky, like understanding how it could work. I mean, at that time, the things that looked, you know, when I was doing all my phylogenetic work back then, the things that looked most similar to Mekosuchidae were, you know, potentially some things from Europe and Asia. So a taxon called Asiatisuchus, which has just been revised recently and kind of untangled a little bit. But there seem to be some similarities with basal Mekosuchidae, with Asiatisuchus, and then also North American taxa. So things like Prodiplocynodon and Brachioradicamsa. So it's kind of, but you know, they're so far away. You're kind of thinking, no, this doesn't really look like a good scenario. And I think the thing is, and this is what has confounded a lot of research into the understanding, you know, crocodilian phylogenetics, and then, you know, evolutionary models that stem from that, is a lot of these crocs look very similar. They're all just variations on a bit of a theme, and some of the differences are quite minor. And, you know, whether they're the sort of things that you want to pin these big, you know, evolutionary scenarios on, I've kind of always felt a bit unsure about it. So yeah, no, it's still, I mean, I think, you know, recently my former student Yorgo Revetsky, when he's been sort of delving into this a little bit more, I mean, the first thing we did was re-examine an unusual partial basicranium that came from the Pleistocene of southeast Queensland that I'd found in a drawer as a student back in the mid-90s, and kind of didn't have a number on it or anything. It was always a bit of a mystery. It looked like the back of a skull of something quite longirostrine, so similar to a gharial. And, you know, we'd had sort of Harpacacamsa, this longirostrine taxon from Central Australia. So I was like, is it something like that that's persisted, or what is it? Anyway, I got Yorgo to have a better look at this specimen, and we ended up determining that it was a Tomostomene. But it suggests that, you know, in addition to the Mekosuchidae radiation, Tomostomenes were also here, potentially since, you know, maybe the late Oligocene, because that's around the time where it looks feasible for things to cross in from Southeast Asia. So I think we've gone from this idea of a single sort of endemic radiation that came in from somewhere we don't really know and then it's diversified and disappeared, to now recognizing that there could be multiple arrivals of different groups of crocs through the Cenozoic, probably through Southeast Asia, but it's not really entirely convincing at the moment. I mean, there are some Asian crocs that Yorgo's identified that seem to, you know, in certain analyses, you can get them to look or to fall close to Mekosuchidae radiation. But as I said before, a lot of these things are so similar, you know, one character change here, or, you know, removal of this taxon there, and it all kind of falls apart. So
Yeah,
I don't know. It's kind of it's fun that it's not a clearly resolved thing. I'm much more zen about it now than I used to be. It doesn't really bother me that much. I'm sure the answer will emerge at some point. But it's, you know, it's cool. You know, I think the diversity that existed in Australia during the Cenozoic with regard to our croc fauna is quite impressive. And, understanding those animals is exciting as well, just in their own right. I mean, you don't always have to be focused on the origin of stuff and where it came from. There's still interesting animals to get to understand as animals doing their thing in prehistoric Australia.
Yeah. So it kind of ties into my follow-up question. What are kind of the defining characteristics of Mekosuchians that separate them from other crocodiles?
Not a lot. It's more like a combination of things, I think, and this has always been the issue. There's not a strong suite of characters that separate them and they allow you to go, oh, it's a Mekosuchide. I mean, early on, things that we thought defined them were having an overbite dentition, having a sort of a palate where the palatine process was quite short, having teeth there was a lot of disparity in tooth size or alveolar size. But all those things have been shown in one way or another to occur in other groups as well. And even within the Mekosuchians themselves, there's a lot of variation in snout shape, body size, tooth form, potentially behaviours that kind of make it very hard to kind of pin down what makes them different, other than the fact that they occur here. One of the things a lot of people, you're probably hoping I'm going to say something about this at some point. A lot of people get excited about the potentially terrestrial Mekosuchians, so taxa like Quincana, probably the main one. That we're getting to know them a bit better now. Slowly, there's material emerging from Central Australia that's giving a better picture of them, but they seem to have had quite deep snouts, and then teeth that have got crenulated carinae, so a tooth form that's referred to as zyphodon or ziphidon, which is similar to what you see in, say, varanid lizards, so like Komodo dragons, and then also theropod dinosaurs, and then the sabechids, which are very distantly related. And this is one of the things I've always sort of wondered about. There is another zyphodont croc that's primarily, I think it's been renamed, I can't even remember the name now, but Pristocampsis, which was sort of similar age to Asiatasuchus.
Okay,
Known from places like Messel, and I think there's evidence for Pristocampsines maybe in South America. I can't remember off the top of my head, but there's always been a lot of apparent similarities between.
Is it is it now called like Bovarusuchus or something like that?
Yeah, that's it. Yeah, Chris Brochu renamed the group and then redescribed some of them stuff. Yeah, Bovarusuchus. Yeah, they seem quite similar to Quincana in a lot of respects. So, I mean, and neither of them's really well known. Probably Bovarusuchus, Pristocampsis thorax, and particularly the one from Messel, they're pretty well known. Most of the skeleton and the skull's well described. But I've always wondered, whether, because it seems like there's more than one radiation of Cenozoic crocs in Australia. There's Mekosuchians and Thomastomines, and probably some other things as well. And I've always wondered within the Mekosuchians whether or not we could have one group that's the more sort of zyphodon inclined ones, that are things like Quincana, that may or may not have something to do with taxa like Pristocampsis or Bovarusuchus, and then a group that's more your standard crocodiloid, so things like Canberra and Asiatasuchus and stuff. And I don't know, I find that intriguing, and I think potentially I'm hoping having a closer look at things like Mekosuchus inexpectatus and some of the other Southwest Pacific Mekosuchidae might answer some of those questions a bit more definitively. And I'm kind of open to things getting more complicated, because I think, simple stories are good, but invariably the real world is a lot more complicated. And it seems to be the way with crocs.
Yeah. Yeah. The more I delve into crocodilian paleontology, the more I realize it is, as much as people like to say they're living fossils that have never changed, they're a lot more diverse and varied in form and function than people give them credit for.
Oh yeah, and I mean that for me is what kind of drove me into my PhD research and the stuff I did after my honours, which I wanted to understand. I mean, initially, like a lot of people, you get sucked into the world of sort of systematics and describing new taxa and doing phylogenetics and stuff. But I think crocs are a really good group to work on because they're still alive, So I, wanted to, I guess, initially, I was looking for, where's somewhere that a group that no one's really worked on before, and a group that came up as being in need of attention were the gorniopholids or gorniopholidids, which is a group of sort of predominantly, late Jurassic and Cretaceous Neosuchian crocs, and a lot of them are from North America, but the original ones come from Europe. So some of the first described ones come from Europe, and they seem to be in a bit of a mess back in the mid-90s when I was looking around for things. But getting into those really got me wondering about the origin of modern crocs, where all these groups that clade we might call crocodilia or Eusuchia, pretty much all the extant ones, the clade that they fall in, how did they originate? Because when you start to look at the diversity of all crocodile forms, you realize that it's quite impressive. There's a lot going on. So what is it about the ones that have persisted today that makes them different? And, how do we understand how that came to be? And initially I was sort of there, doing all this, like, investigating, poorly described gorniopholidids and other things. But slowly but surely, my focus changed to trying to understand the origin of modern crocs, and of course, like, gorniopholids became part of that question. And I was really lucky. I ended up, it's kind of a bit of a strange story, and it came full circle in the end. But I ended up going to Europe and working with a guy named Dino Frey in Karlsruhe, in the Staatliches Museum für Naturkunde there. And Dino had done some amazing work on body stem anatomy of alligator, and then also stuff looking at the bracing mechanism of crocs. And I think, that really excited me, and it sort of gave me an insight into potentially what all these little lumps and bumps on bones and things actually mean. And it goes back to, the stuff that I said I was doing during my honours, because you spend so much time as a paleontologist just looking for lumps and bumps on bones without actually really thinking, what does all this mean for a living animal? And I think once with crocs, because you can go out, you can dissect them, you can see where muscles attach, you can see how they move, how they swim, how they run, and you can start to try and put it all together. You can really build a very different understanding of potentially how they might have evolved. And one of the things that Dino had shown that I thought was really cool, and I thought it seemed like a good way to try and understand how modern crocs had sort of come into being, was he'd recognised that everyone knows crocs are armoured, Okay, and they've got bones in the skin that sit beneath the scales. But I don't think what a lot of people appreciate is that down the middle of the back, starting at the base of the neck and extending all the way to the tail, the muscles that run either side of the vertebral column, the epaxial muscles, in crocs, those muscles insert into the base of the osteoderms in the skin. So the skin becomes part of what we refer to as the bracing mechanism, the way that the vertebral column is stabilized during different types of locomotion. Because as soon as an animal, lifts its body off the ground, there's all sorts of forces that begin to act on the vertebral column, and it needs to be sort of stiffened and braced against those forces. And it becomes more and more of a thing the heavier and heavier you get. So you don't really see modifications in skeletons that relate to vertebral bracing kick in until things kind of get over about 50 kilos or so. So it becomes really evident when you look at a horse or an elephant, or a big croc. And mammals, when you look at their vertebral column, the way they brace it is just by increasing the bulk of the epaxial muscles in the part of the vertebral column that sustains the greatest amount of mechanical loading. And that's sort of generally it's the sort of center of mass. So for something like a bison or a horse or a rhino, that's sort of over the shoulder girdle. So what you see in that part of the vertebral column is really elongate neural spines or spinal processes that indicate you've got a very big diameter, big mass of epaxial musculature that when it contracts, it sort of stiffens the vertebral column that allows them to, move their legs and run and walk and do whatever they need to do. So, and without sort of flopping over, basically, without that extra bracing, they would have real issues moving around on land. Crocs, on the other hand, when you look at a big croc, there's none of that going on with regard to increased bulk of the epaxial musculature. You can't see it. All the vertebrae, the spinal processes are all the same height all the way through the trunk. But what you do see is a lot of variation in the arrangement of the osteoderms that are attached to these epaxial muscles. And it really gives you a key to understanding how crocodilian locomotion works. So the basic kind of model is a mechanical system that's pretty much just an I-beam. So, anytime you look up in a big building, the main sort of steel beams that are supporting things have like a central beam and then one above and one below. And it's always the same height all the way along. And a croc's vertebral column is essentially an I-beam. So the neural spines are that central beam of the I-beam. The lower truss of the I-beam is made from the transverse processes. And then the dorsal or the upper truss is made from the osteoderms. And in between are the epaxial muscles. And when they contract, they pull all that together and it creates a rigid I-beam. It's pretty cool to sort of recognize a mechanical solution in an anatomical system, or vice versa. It's basic sort of mechanics in an animal operating and doing its thing. So with living crocs, they have pretty heavily segmented dorsal shield. All the osteoderms on the back are sort of arranged in transverse rows, and there's there can be upward of 8 to 10 per row. It's only the middle 4 that are actually connected. to the underlying apaxial musculature. But that's you look at that and go, wow, it's got a lot of inbuilt flexibility, which is great for things like moving from side to side during swimming, and it also provides a sufficient stability when the crocs get up and do things like a high walk. So modern crocs, living crocs, have got quite a diverse locomotor repertoire. So they can slide on their belly on the mud, just sort of scoot along, pushing themselves. They can get up and high walk with the belly off the ground, which requires that sort of bracing mechanism to kick in. But then they can do things like, a number of taxa can gallop, sort of bound along, which requires the whole vertebral column to bend dorsoventrally. So this is where that kind of segmentation of the dorsal shield becomes important. And then, of course, they're very good at swimming, and they can swim just by undulating the tail from side to side with the legs tucked in, and then any combination of starting to use the legs in combination with the tail, or just using the legs and sort of doggy paddling along. But what you see is in all those different styles of locomotion, the thing that sort of restricts the extent to which they can move from side to side or up and down or whatever is the dorsal shield, this series of osteoderms in the skin, because it restricts the flexibility of the whole system. And what I think is really cool is you soon realize when you look at the huge diversity of fossil crocodilians that are out there, is that there's a big diversity of a big range of variation in the expression of this dorsal shield. So most fossil crocs only have two osteoderms, one on each side. They have what we've described as a biserial shield. So it's in rows, transverse rows, but there's only one osteoderm either side, which is very different to what you see in an extant croc, where there's could be up to 10. And a lot of them, and I kind of got into it with the gorniofolids. They have their osteoderms are quite rectangular, and they have this big spike on the side that seems to sort of slot into the back of the osteoderm that precedes that one. So you get this interlocking series of osteoderms with spikes fitting under each other. And you see that in a lot of taxa. And then as you start to get close to the modern croc radiation, crocodilia, Eusuchia, whatever you want to call it, you start to see this dorsal shield beginning to fragment. And I think the thing is, when you understand how the dorsal shield affects the flexibility of the trunk, for a lot of these fossil crocs, they wouldn't have been able to move the same way as living ones. They don't have nearly as much capacity for flexion, which would have really inhibited the way they swim. So they can't move the body in a sort of sinuous line from side to side. It would have been great for high walking, and indeed it looks like crocs, the crocodiliforms or crocodilomorpha, that lineage probably started out being predominantly terrestrial, small terrestrial things getting around, potentially with quite an active metabolism, because they weren't good swimmers. Being a good swimmer is a sort of trait that's emerged much later and probably a number of times within the evolution of crocodilians. And I think for me, the big kind of breakthrough came when I recognized, and this was, a lot of this stemmed from really trying to understand crocodilian anatomy in a holistic sense, the link between what was going on with how the the dermal skeleton brace the trunk, and how that would relate to the vertebral column and specifically the intervertebral joints, because all extant crocodilians have what are referred to as procoelous vertebrae. So they've got like a ball and socket joint between each of the vertebrae. And initially it was always assumed that that was some kind of flexibility thing. But all these other lineages of fossil crocodilians have amphicoelous vertebrae, so vertebrae that are essentially flat either side. And in terms of flexibility, that's actually a more flexible joint than a ball and socket joint. But, you know, you can't look at it just in terms of bone on bone, because there's any joint, and vertebral joints are no exception, has got a lot of cartilage around it. It could be synovial, it could be fully cartilaginous. There's a lot of ligaments holding the vertebrae together. And then, of course, there's all these muscles and tendons around it all. Yeah, so I got right into that, and it became apparent that, you know, you see amphicoelous vertebrae in crocs that have this biserial shield with all those interlocking spikes along the side. And it seemed like that sort of system is very rigid, and the dermal skeleton is actually sort of protecting the vertebral column from any sort of shear loading. That, you know, if you've got, oh, you disappeared. No, you came back. So if you've got an animal where it's got amphicoelous vertebrae, it sort of needs to have an interlocking biserial shield to sort of counter all the mechanical loads that happen when it high walks. But as you start to muck around with trying to increase the flexibility of the trunk, which is probably a thing that relates to crocs starting to try to, I guess, improve their swimming capabilities, the dorsal shield has to open up and segment. And as soon as you begin to do that, in a mechanical sense, it exposes the vertebral column, and particularly the intervertebral joints, to shear loading. And it seems like the advent of procoelous vertebrae, and you see this kind of start to happen in a range of unrelated taxa. They begin to get sort of incipient procoelous joints, incipient ball and socket joints. That seems to go hand in hand with segmentation of and increased flexibility of the dermal skeleton and the trunk, and the emergence of modern crocs seems to relate to getting it all together, because you need to have procoelous vertebrae to also have a flexible dermal skeleton or a flexible trunk that stems from a segmented dorsal shield. So when I realized that, all of a sudden this sort of question of how did Eusuchian crocs come about began to make sense in the context of how these animals move and what might be advantageous or not. And I think what you see with Eusuchians is a highly sort of specialized locomotor system that incorporates a range of modifications to the dermal skeleton and the vertebral skeleton that do two things. One, there's a lot of flexibility in there, but there's also a lot of stability as well from the procoelous vertebral joints, because they really counter all the shear. So it means that Eusuchians are the first kind of group of crocs, you know, whether it's a monophyletic group or not doesn't matter. I'm just talking about it as an anatomical system. They're the first group that have come up with a way to have a full repertoire of locomotor capabilities. So they can run, they can walk, they can slide, and they can also swim very effectively with lateral undulation. And importantly, they can do that all and still get big. And I think that's the key to what's sort of made them such a successful radiation, and probably why they're the radiation that has persisted. Because up until the emergence of the Eucekians, if you tried to have if you're a croc and you tried to have all those locomotor capabilities, but you still had amphicoelous vertebrae, you couldn't get very big. And it's probably one of the reasons why a lot of the crocs that have that combination of things are quite small. So taxa like this is like the Theriasuchids, Berlansiasuchus, Bernasacea, they're all little. And anything that gets bigger probably either stays in the water or starts to go down a much more aquatic path. And I think like the Diosaurids, all the Salisburyans, they've all gone down this sort of, just dispense with trying to have the capacity to do stuff on land and become highly specialized aquatic animals and really sort of focus on flexibility of the trunk, but at the expense of being able to do stuff on land. And the funniest thing for me, and this is where it comes full circle, like I was over in Europe looking at all these predominantly European taxa, a few African things, trying to understand, how.
Yeah, I was just about to bring up the Metriorhynchids.
Sorry, the Metriorhynchids. Sorry, what did you want to ask about?
Yeah, I was about to say with the Metriorhynchids, with them being highly specialized marine forms that didn't need that spinal strength to support their weight off land, they could completely sacrifice their osteoderms for maximum flexibility.
Yeah, so you see that in that Galatasuchian radiation, and it's still not really clear where that radiation kind of fits in. But initially, things like Stegosaurus, they've still got a dermal skeleton and a paravertebral or dorsal shield, but it's starting to get really reduced. And then, obviously, to increase the efficiency of their swimming, particularly with regard to axial undulation, they've dispensed with it altogether. So by the time you get to the Metriorhynchids, there's no dermal skeleton at all. They're swimming with full undulation of the trunk and the tail together to create much more effective thrust production. And the limbs, whereas in crocs today, they're sort of they can dog paddle with them, they can use them for steering and stuff. With Metriorhynchids, it seems to have become initially fully a steering thing, and the limbs have become much more paddle-like. And then with time, they've probably evolved a type of underwater flight with the hind fins, because you see the front limbs get quite short and stubby and don't look like they could do much other than steering, but the rear limbs become very flipper-like. And when you see flippers in turtles or seals or anything, they're typically used for underwater flight because you can generate thrust on the recovery stroke as well as the power stroke. And Dino and I actually recorded in Osteoderms, the African dwarf croc, some swimming where only the hind limbs were kind of used, not fully in underwater flight, but you could start to see, like you can see in a lot of freshwater turtles, the start of a recovery stroke that's generating lift. And so it doesn't seem that implausible at all to sort of, if a group of crocs decided to go with that swimming mode, that the next step is to start to get flippers and to start to use the limbs like flippers in penguins or seals or turtles. And they start to do different things with the tail. They start to get a tail fluke. So pretty crazy the the extent to which they've specialised with regard to aquatic locomotion. But it all starts out with that basic crocodilian formula, with having the osteoderms being part of the way that movement's initiated and constrained within the trunk.
Yeah. So basically, in conclusion, crocs used their osteoderms almost like a weightlifter's belt to provide spinal stability.
Yeah, that's a good way of putting it. So once if you're a weightlifter and you're trying to lift heavy loads, if you take your belt off, you could do some damage to your back, and osteoderms kind of do the same thing. And obviously, the size of your belt, how tightly you wear it, all that sort of stuff probably affects how you lift, and it's the same with Crocs. So I found all that stuff that's been really interesting for me, and the thing that brought it all back to Australia for me, just to wrap it up, is just as I was finishing my PhD in Germany, news of a fossil croc emerging in the Cretaceous deposits of central West Queensland came about, and I started working on that specimen, and it turned out to be a spectacular, nearly complete skeleton, and we found more of it, including a skull. It was a thing that we described as Isis 40 duncani, and it seems to be on the cusp, if not there, at the origin of modern crocs. So it's got a fully sort of modern dermal skeleton that looks just like an alligator or a crocodile, but the vertebral column, it's just starting to get incipient procoelous vertebrae. And it's about 100 million years old, so it's right at the right time for the sort of transition to modern crocs. Whether it is a modern croc or not, we've now sort of recognised that it's similar to a thing from South America called Susisuchus. So it seems like there's this Gondwanan component to the question of the origin of modern crocs, and it may well be that modern crocs, if they didn't originate in the eastern part of Gondwana, maybe in Australia or possibly the west in South America, it was somewhere around here, and they may well have been here since then. So that has really, unfortunately we don't have a fossil record from about 90 million years through to 55, so there's a huge black hole in Australia for what was going on. But it throws a bit of a spanner in the works when you think that Eusuchians could have been in Australia all that time, and all sorts of cool stuff could have been happening. So back to the question of the origin of Mekosuchidae, I mean, I'm sure there are many gaps to fill in that story, and they're potentially happening in the latest Cretaceous and the earliest Cenozoic. So I think that's where some of these answers are going to lie. I don't know when that's going to happen, but I reckon at some point we'll look back at this period where we're scratching our heads trying to figure it out, and it'll all make sense. It'll be cool when that happens.
Yeah. I have one question that I definitely want to ask, so I'm just going to ask how much time do you have left?
I'm okay. I'm sitting here on my veranda, finish my coffee.
Okay. Yeah. So the first Mekosuchus I ever learned about as a kid was Trilophosuchus. I'm trying to look for research. I saw you wrote something on them. But can you talk about Trilophosuchus real quick?
Yeah, so Trilophosuchus is from Riversley, so I think it's about sort of 23.5 million years old, so from Northern Australia. It was described by Paul Willis back in 1993 and was one of the crocs that were sort of put forward initially in this idea of a endemic Australian radiation that became the Mekosuchidae. Recently, I had my former student, Yorgo Ravetsky. He re-examined Trilophosuchus. We CT'd it and reconstructed all the bones digitally and put the endocranial cavity together and stuff. And it's really cool because it's small. Like, the skull's only as long as your hand, or fit on your hand. So the entire animal probably less than a meter, 80 centimeters or so. It appears to be that particular individual looks to be adult-ish, sub-adult, from all the sort of maturity indicators that we can gauge. So it doesn't look like they got much bigger. And it's got, the name indicates part of the peculiarity of the skull. It's got three sort of crests along the back of the cranial table, hence Trilophosuchus. And it seems to have had quite a deep skull, so similar to some of the, potentially Zyphodont kind of things, short, deep skull. What that means in terms of its sort of ecology, I mean, I don't think it's probably that different to like a dwarf caiman or something. So, still a semi-aquatic croc that may have spent a little bit more time out of the water, in the forest or whatever, doing its thing. I wouldn't necessarily refer to it as terrestrial. I know at some point Paul Willis might have, I think he drew a cartoon or something showing Trilophosuchus in a tree just as a bit of a joke.
I think I've seen that picture.
Yeah, as a drop croc, which, been ruining the day he did that, because for ever since then, Trilophosuchus and some of the other river crocs have been, people got excited about them being arboreal, but I mean, there's nothing about them that would have allowed them to climb trees. I mean, think about crocs. They don't really have very good capacity for flexing the digits in their hands or feet. So it'd be very hard for a little croc to scramble up a tree. I mean, freshwater crocs today, Australian freshwater crocs, do kind of, work their way up a submerged log out of the riverbank or something, and sometimes end up on low-lying branches and things. But I wouldn't call them arboreal. They're not like flipping around in the trees and swinging and jumping and stuff. And they definitely can't climb trees the same way that varanids can. Anyway, but doesn't take anything away from the fact that Trilophosuchus was a very unusual very little croc that was, probably getting around in the streams and forests of ancient Australia 23 million years ago. And it's just one of these crocs that are, unfortunately, no longer with us anymore. It's kind of sad. Like, we had in Australia quite a diversity of crocs right up until, a few million years ago. And then today, while Australia is known as somewhere that is very much crocodile country, particularly Northern Australia, the crocs that we've got here today, the Indo-Pacific croc and the Australian freshwater croc, seem to be relatively recent arrivals. Like, we've not, seems like some kind of crocodilus, probably not porosus, but maybe similar to it. The best sort of evidence we've got for them here probably starts around 3 to 5 million years ago. So somewhere around there, crocodilus arrives in Australia. So it's only been here, a few million years, and it's from that point that Australia really begins to dry out. And I think, the Mekosuchidae and other crocs, the Thomastomines and things that were here, a lot of those are found in inland river systems that existed in central Australia and southeast Queensland and western New South Wales and stuff that have since dried out. So a lot of the habitat that used to be probably quite favourable for crocs across most of the Australian continent, over the last few million years, it's disappeared. And I think with that, all those crocs seem to have fizzled out as well. And then porosus is, the Indo-Pacific croc is such a large dominant species that pretty much wherever it occurs, it becomes the number one croc. And I think, it's sort of taken over coastal habitats that may have been the realm of some Mekosuchidae. And it dominates today as it does through most of its range. And the Australian freshwater crocs pretty much occur away from places where you get Indo-Pacific crocs, and the reason for that is if they do go into those areas, they get eaten. It's a croc eat croc.
Yeah.
It's a croc eat croc world out there. So, one of the things that's made crocodilus such a successful species is its ability to tolerate salt water. They've got lingual salt glands, so salt secreting glands in the tongue. So any animal that goes into seawater has to deal with excess salt building up in its blood. You need to get rid of it, and they have that capacity with glands in their tongue. So all crocodilus can do it. Porosus just seems to do it better, and it's a bigger and meaner crocodile than a lot of other ones. So freshwater crocs, Australian freshwater crocs can survive in saline water by secreting salt, but they can't survive if there's porosus around. So that's the thing that restricts them to freshwater habitats. It's not their inability to deal with salt water, it's the inability to deal with big mean porosus.
Yeah. The reason the freshie is called a freshie is because it only lives where there aren't salties.
Pretty much, yeah.
Yeah. But that was actually going to be one of my last questions that I really wanted to ask was what led to the decline and extinction of Mekosuchidae on mainland Australia. I mean, on the islands, we know it's pretty much as soon as humans show up, Mekosuchus dies. But on the mainland, like you said, the interior dries out, and we have large crocodilus show up pretty much at the same time.
Yeah, that's kind of, I think, the key of it. I think it's just this gradual drying out of the Australian continent. So, we used to have the Lake Eyre Basin. It's the main drainage basin that covers a large part of Central Australia. I mean, we're finding crocs in that, up until a few 100,000 years ago. But today, it's pretty much a salt pan. And the rivers that flow into it are quite ephemeral. They only really sort of flow when there's heavy rain. So you just don't get those persistent conditions that crocs need. Pretty much the only areas where that does persist today are in coastal river systems. So where you get porosus. And then Johnson and I sort of ekes out an existence further upstream away from the reaches of porosus.
Yeah. So, correct me if I'm wrong, but the last living species of Mekosuchidae on mainland Australia was quincana, right?
Probably quincana. I mean, we've got and as I sort of indicated this before, it's pretty hard to be sure about it because the remains that we have are sort of limited to things like isolated teeth and osteoderms and things. So, there are some sort of zyphodont teeth maybe from deposits around 30,000 years ago, and they could be quincana. There could be something else, I don't know. But I mean, sort of suggests, that's around the demise of Mekosuchidae on the Australian mainland. But, sort of, you got to wonder what also happened to things like the Thomistomines. So, we had Gungarumundu, that one that we described recently. Probably, the last million or so years, 1 or 2 million years ago in southeast Queensland in river systems close to where I live now. It's gone as well. Crocs haven't really persisted in any of our bigger river systems that seem to have been much bigger back during the end of the Cenozoic coming into the Pleistocene. It seems that the advent of ice ages, which in Australia really were very much characterized by extreme aridity. That seems to have been the nail in the coffin for the last of the Mekosuchidae. And probably a lot of other elements of our fauna as well. And, when you think about the demise of megafauna, seems to go along with that. And for many of those big Mekosuchidae, things like Palodyrex, and some of the last Baru and stuff, I mean, their diet would have been big megafauna. So you remove the rivers, you remove the prey, there's not much left.
Yeah. I was about to ask about Quincana, what you believe his ecological role was. Do you think it is as terrestrial as paleoartists like to make it out to be, or do you think it is maybe something like a Cuban croc that was still semi-aquatic but just ventured onto land more frequently than most other crocs?
Yeah, I think the main thing to recognize with Quincana is, and other Xiphodont crocs, is that the snout or the rostrum and the teeth indicate that they feed in a different way to your standard broad-snouted croc or alligator. So broad-snouted croc or an alligator is a semi-aquatic ambush predator. They, lie in wait on the banks of a river for something to come along for a drink, launch out, grab on, and then that broad, flat skull is really good at resisting torsional load as they try to drag their prey underwater and then, go into a death bin and dismember it and all that sort of stuff. With a deep snout and with Xiphodont teeth, I should point out, with that broad snout having lots of big conical teeth of different sizes along a sort of undulating tooth row, is all about, getting the best maximum grip on your prey. Whereas with things like Quincana and other Xiphodont crocs, the snout shape and the tooth shape is more akin to what you might see like in a Komodo dragon. And it sort of suggests that rather than holding on and, dragging things away, these things are biting and then relying on the damage from the bite. So it's like a slash and tear style feeding rather than a bite and hold on death roll kind of thing. So that's important. So a different style of bite and a different way of potentially killing the prey. Whether that works better on land or in the water, I mean, you could still be a semi-aquatic ambush predator to some extent. I mean, it's a little bit harder when your snout's deeper and, you're not as well concealed in the water as a broad, flat-snouted croc, or croc with a broad, flat snout. So, yeah, it kind of suggests that they're feeding differently. They might have been doing it on land, but if you start to reconstruct them as running around chasing things down like lions and stuff, I mean, I don't know. They don't necessarily have, because these things have evolved from animals that have got an aquatic sit and wait metabolism. So they're not like descended, they're not like, remnants Venusuchians that have maintained that potentially active metabolism. They've evolved from ancestors that had a slow metabolism, that don't really have the capacity for sustained locomotion, particularly on land. So maybe they weren't feeding as frequently at the edge of the water as other crocs. Maybe, when they got their prey, they were relying on, blood loss or something to do the damage. Kind of similar to Komodo dragons. I mean, they rely a lot on, it's been shown recently that they're venomous, and that the damage from the bite and the venom is something that allows them to ultimately dispatch with their prey. But Komodo dragons can kind of jump on things and wrestle them to the ground and stuff, and maybe Quincana could do stuff like that. I'm not I'm not sure. I'm a bit skeptical. When you look at Quincana or other Xiphonont crocs, and then you compare the skull and the snout to other living crocs, they're not that different to things like dwarf caimans, Paleosuchus, which has got a pretty deep snout.
Yeah.
They're small, and you don't see them running around killing capybaras and stuff, chasing them. They're still essentially aquatic predators or semi-aquatic predators, and they take smaller prey because they can't really hold on to big things as well.
Yeah. Yeah. So we say something the size of a Quincana probably targets something more like small, mid-sized wallabies or wombats, maybe something like that.
Yeah, maybe. And whether it's actively hunting stuff on land, I think is debatable because it wouldn't necessarily have the metabolism to do that. I mean,
Yeah.
even like a Cuban croc, they can run around a bit for 20 seconds or something, but then they got to stop and get it together again before they do it. So, I mean, they're still relying on surprise and ambush to capture prey. I definitely wouldn't consider them active terrestrial predators.
Yeah. Are Quincana fossils almost predominantly found in heavily forested areas? At least when there were fossils laid down.
No, well, most of the fossils of Quincana come from the same deposits that produce other croc fossils. And those are the ones where fluvial systems or lacustrine systems where things get fossilized anyway. But what is
Yeah.
interesting is that the very first specimen, the holotype of Quincana forterostrum, came from a place called Tea Tree Cave in North Queensland, and that area, although it's like a cave and it might have been a pitfall trap or something, it's fallen in or something. It seems to have been about 11 kilometers from permanent water. So that sort of suggests that, maybe they were capable of getting around on land and it's ended up that far away when it was eventually fossilized. But the majority of fossils of Quincana are found in the same deposits as other crocs, which kind of makes you think they're still being very croc-like. And, no matter what you think about the way Quincana fed or anything, it would still have needed to probably build a nest, probably near the water somewhere. So breeding behavior would have probably been pretty similar to other crocs. So close to water. I don't know.
Yeah.
It's interesting. I'd be excited if more definitive evidence emerged for the terrestrial capabilities of things like Quincana, but at the moment, I kind of see it pretty similar to a dwarf caiman.
Yeah. Just really souped up, really made sure to eat its Vegemite.
Yeah, well, they're not that much bigger either.
I thought Quincana got like 4 meters.
No, there's a couple of specimens that we thought might be big Quincana, but the bulk of them seem to be, maybe like 2 meters.
Okay. Yeah, that's very large Paleosuchus size, yeah.
Yeah, so I think people can get easily carried away. I've gotten carried away in the past, but I've started to realize that a lot of these things that we thought might have been big Quincanas probably was something else.
Okay. Kind of disappointing, but okay. I was about to ask if you find Megalania or now Varanus priscus in the same deposits that you find Quincana.
Yes. So, for instance, like one of the places where you get Quincana is in Chinchilla, which is also one of the areas where we get Megalania. So, I mean, and both of them are quite rare in those deposits. So, that could indicate that it's a more terrestrial animal. That's not one that's as tied to water as some of the other crocs that appear in those deposits. But we'd need to really understand the taphonomy of those sites to properly understand what has been found and what we're finding now relates to the broader environment and the paleoecology of those animals. I mean, you can very quickly just go, oh, got this Zyphodont tooth, it's quincana, it comes from chinchilla, and sort of jump to all sorts of conclusions. But you need to understand, how did that tooth get incorporated into those sediments, and what sort of environment, depositional setting were those sediments, and all that sort of stuff before you can really answer questions around paleoecology. And unfortunately for quincana, we're sort of stuck with the fact that, at least for a lot of the ones that occur in places like that, all we really have are things like teeth. So there's not much else. So it could easily be something else. And hopefully, in the near future, there will be discoveries that will shed light on that. And I suspect there's a little bit more than just quincana going on, as is the case with some of the other crocs that are there. So like with the Darling Downs area now, we've got a big broad-snouted thing, Palodyrex. It used to be Palmanarchus. And then we've got the Thomastomene, Gungaramundid. And there seem to be other potentially other big, not very exciting snouted crocs doing their thing there. And then there's also, quincana or something like it. So pretty diverse croc fauna over that period in that area, that I think still has a little bit to reveal about itself.
Okay. I always want to make sure to ask if you worked with Mekosuchidae, the name genus for this entire group, if you've ever done any research on them.
I have, actually. It's one of the I spent quite a bit of time in Paris a few years ago looking at all the material there, and I would like in the near future to write that up at some point. There's a lot of good material of Mekosuchidae and expectatus, and I think having it properly sort of described and characterized will really sort of give us a better understanding around what is a Mekosuchine, because ultimately it depends on what's closely related to Mekosuchus. And I think there's a whole other story going on there in the Southwest Pacific. There's a range of crocs out there that some of them look like each other. I don't think Mekosuchus inexpectatus is the same croc as Mekosuchus from places like Riversley. I think they're different taxa.
Okay.
And then, so there's potentially like a Southwest Pacific radiation of things. There's a Oligocene radiation of things. And then the other kind of cool stuff that I'm been working on is from New Zealand, from the South
I was about to
Island,
ask.
New
I
Zealand.
thought I heard that there was some sort of crocodilian on New Zealand.
Yeah, and it seems to, it's been a slow process getting all that material together, but it seems to be different to all the Mekosuchine. I don't think it's a Mekosuchine. My suspicion, and I think there's more than one of them. We've got a few replica or repeated elements in the assemblage that indicate more than one species. And if anything, it looks like quite a plesiomorphic croc. So my suspicion, I kind of presented this at a conference a few years ago, is that it's probably the croc equivalent of the tuatara. There's this animal that's probably been there for quite some time. And
it's like the last remnant of archaic lineage.
Yeah, so it's I find it interesting, and going back to that whole thing with Isis-Fortia and the fact that modern crocs have been in Australia since at least 100 million years ago. So It's around 80 million years ago that New Zealand breaks away from East Antarctica. So it's pretty much been isolated since then. And the fauna that's persisted there today, so things like the New Zealand wrens, the type of early passerine perching bird, tuatara, they're all derived from lineages that we can trace back to around sort of 80 to 70 million years ago. So I suspect the croc is part of that mix because, there's nothing in New Zealand in the Miocene that suggests faunal exchange with anything else in the Southwest Pacific. The stuff in New Caledonia and Vanuatu and Fiji, it's different, and nothing seems to be able to get from there to New Zealand, even during periods where more of Zealandia was emerged. So I know that's a whole other little interesting subplot that's going on in the Southern Hemisphere. It'll be good to get to the bottom of that. So there's lots of cool things, working on lots of good stuff, and hard to know which one to focus on.
Yeah. Just want to make sure you're still good on time if you need.
No, it's okay. You're the one who I'm like lunchtime here. You're getting late over there.
Okay, yeah. I just didn't want to impose on your schedule for the day. It's all so.
No, you're okay. You're okay.
Okay, so I was about to ask about Mekosuchidae. It's true that we have unmineralized bone remains of those guys, right?
Yeah, it's not. It's sort of sub-fossil-ish, I guess.
Okay.
I mean, I know where you're going, and I had also thought this as well. Is like because it's only maybe
What,
between sort
3,000,
of
4,000 years old?
3,000 to around 1,800 years old.
Only 1,800. Wow.
Yeah, potentially. That's sort of around the last sort of point where we get it. So yeah, that sort of instantly thinks, well, maybe there's some DNA preserved in there or something. But where it occurs in tropical New
The
Caledonia,
tropics.
in
Yeah.
in the tropics, in a cave that's open to seawater. It's a very humid, saline environment, and DNA and soft tissue just deteriorates super quickly in that sort of setting. So it's nothing like finding a frozen woolly mammoth in the permafrost. It'd
Yeah.
be good.
Unfortunately.
Unfortunately, I don't know. Maybe at some point there'll be ways to extract something from that sort of bone, but as far as I've understood it, the humidity and the salinity of that cave pretty much destroys any viable soft tissue quite quickly. So, unfortunately, no. I did once hear a story that I've never been able to verify of I think it was from Tim Flannery, of a dried croc skull stuck on the entrance, over the entrance to a hut or something somewhere that might have been a Mekosuchus or something, but have never been able to verify that. Someone out there, let's try and find this dried croc skull if it ever actually existed, and maybe that's from one of these last remaining Mekosuchidae, which would be pretty cool.
Yeah. I was about to say, obviously, use it for phylogenetic research, but on a side note, I'm much more willing to fund a Mekosuchus cloning project than a woolly mammoth cloning project. Just
I personally, the whole de-extinction thing, like I'd be excited to find a dried skull of Mekosuchus, but I think the bigger question around is it worth doing this? I think it's the animals that would be created are never going to be the same as the ones that actually went extinct. And I think it's far more valuable to learn from past extinctions than to try to undo them, because we've still got so many animals today on the cusp of going extinct, and that's where funding and efforts should be focused rather on things that have gone. Because otherwise, if people think you can de-extinct stuff, then who cares if stuff goes extinct? What does it matter? And it matters a lot.
Yeah.
So I think that's what we should be focused on, not trying to bring stuff back that's going to be some weird chimera that can only survive in a lab or in a zoo. You're never going to be able to release it and have it sort of recreate the ecology that once existed in these places. So I think it's sad that a lot of things have gone extinct, and that it's been at the hands of people. But I think we should learn from the lessons of that and really try to preserve what we've still got. I mean, I think it was only this year was the last white rhino died, and that was the end of that,
Oh yeah,
that species.
what's up? Yeah, I remember reading about that.
And across Australia, we got so many really unique animals that are on the brink that could really do with conservation efforts and preservation of habitat, and that's what's needed. Not all this money going into de-extinction of things that unfortunately are gone. But I think it's much better to reflect on that as something that we don't want to have happen again.
Yeah.
So for me, Mekosuchus is always going to be an animal just to ponder. Love it if they were still around, but unfortunately they're not.
Yeah, a fantasy dream, I know, but still a fun dream. But
yeah,
so Mekosuchus in its environment, I know there's all. It's kind of interesting that Mekosuchus on New Caledonia also shared an environment with a large varanid, kind of how Quincana shared the mainland with other large varanids. Do you think that's a kind of a pattern with terrestrial Mekosuchines, or well, not terrestrial, but more terrestrial Mekosuchines, where they had to share habitat with large varanids?
Well, see, I question whether Mekosuchus inexpectatus was terrestrial. Like it's found in a coastal cave. Most of the water system, the waterways in New Caledonia connect with the ocean, and it's the sort of place that pretty much the only way to get there or get off it is via the ocean. And I think we've got more material of Mekosuchus from Vanuatu that sort of looks, it's a second species, Kalpokasi, that looks like it's Mekosuchus from the stuff that we've got. So that sort of suggests moving, at some point, ancestor of one or both of these things moving between New Caledonia and Vanuatu, and that's the realm of the swimming croc. So even though it's tempting to want to think of them as terrestrial animals, they're still crocs, and they're going to be most at home in or near the water. And just because there's a varanid nearby doesn't really change that. I mean, there's plenty of big varanids getting around in Australia today, and we're not talking about any of our extant croc fauna being terrestrial, even though they, can get up and walk and get across dry land quite effectively. Johnsonite can gallop, but that doesn't make it a terrestrial croc.
Fair enough.
I think I like to think of crocs as being really versatile, and I think that's part of what has been the secret to their success, or at least understanding why they've been successful. They are versatile in terms of their behavior, their diet, their ecology, their locomotion, and that's been part of the formula. And being able to do a bit of everything is a good strategy. So being able to swim, being able to walk, being able to high walk, gallop, catch stuff on land, catch stuff in the water, catch stuff underwater. I mean, you're not tied to any one ecology if you can do that. It's the croc way.
Yeah. Was there also a species of Mekosuchidae or some other small crocodilian on Fiji?
Yeah, a thing called bolia, which it's quite different to Mekosuchus. There's some similarities there, but it just highlights that through the Southwest Pacific, there was a diversity of crocs during the latter part of the Cenozoic, maybe much earlier. I mean, places like Fiji, it's a pretty recent volcanic island, so it can't have been there too long. And the thing that I do find interesting is that while some of these Southwest Pacific crocs presumably could move between these islands, a lot of these islands are a long way from each other, but they're also a very long way from mainland Australia or even the Solomons and the Solomon Islands and New Guinea and Southeast Asia. And today, we've got one of the most capable swimming crocs of all extant species, Crocodylus porosus, that has got salt tolerance, that has a range that, includes a lot of islands and a lot of marine barriers and stuff, but rarely do porosus end up in places like Vanuatu or Fiji. There's a few, it seems like an animal, drifted off course during a cyclone or something that's ended up there, but never really sustained any natural populations in any of those areas. So if porosus can't get out there and establish viable populations, how did these little Mekosuchidae do it? I don't
Yeah.
know. It's interesting. I think the possibility that you're looking at a sort of remnant group of crocs from irradiation that might have something to do with the submergence of Zealandia, and there were once more widespread across parts of the Southwest Pacific that have since become submerged. I mean, I think that's a real possibility. I don't know. It's another area of research that I think the answers are far from clear at the moment, and the story is yet to be told.
Yeah. And did this Fijian crocodilian, did this go extinct? Does extinction kind of correlate with human arrival, or did it predate human arrival?
I can't remember offhand. I suspect a lot of these Southwest Pacific crocs, usually the remains are recovered from what initially were archaeological sites. So looking
Okay.
at areas where Polynesians and pre-Polynesian Plata peoples were beginning to explore and populate these islands. So they're either associated with those or just before them. And I can't remember exactly what the story is with Volia. But I suspect it's probably a Holocene thing, so not that old. So yeah,
Okay.
very very likely that it's potentially something that was driven to extinction through the arrival of people in one way or another, potentially. But I'm not sure. With Mekosuchus inexpectatus and Calpacasi, it definitely seems to disappear once human settlement seems to take shape in those places. And we found like the Calpacasi stuff that we've been working on recently comes from middens that were created by people. So people were clearly consuming the crocs there. I'm not entirely sure what the story is with Volia.
Okay. So have you done any research with any other Cenozoic Australasian reptiles?
Dabbled a little bit in the turtle stuff, but it's not really my thing. But yeah, mainly the crocs and some bird stuff. But again, it's not really my speciality. I just helped out because there's crocs in the same faunas.
Yeah. I just had to ask because I noticed your profile picture has, I'm guessing that's probably like the rainbow serpent. So I was wondering if you did like work with like women or something like that.
No, not on the snake stuff. I haven't ever done any snake stuff.
Yeah. Well, from what I heard, it is infuriating, frustrating. So
Yeah, I've got my hands full with crocs and dinosaurs at the moment. That's for sure.
yeah. Oh, that reminds me. I'm just going through your ResearchGate profile. You do see a lot of work with Australian dinosaurs, and I know Australia doesn't have the best fossil record, most complete fossil record. But do you want to talk about your research with Australian dinosaurs at all?
Maybe that's best for another session if you want, because it's probably
okay. Open up the other half of your research. So
yeah.
Yeah.
No, I think to conclude, I mean, I initially ended up getting into crocs because I was interested in dinosaurs, but I soon realized like crocs are a really good gateway to dinosaurs because I think there's a lot you can learn from studying living and fossil crocs and their anatomy and behavior and stuff that is very transferable to dinosaur research. So even though I initially would have preferred to go straight into dinosaurs, I'm very glad that I got kind of sidetracked and distracted by crocodiles for a long time because that has really given me a good grounding in comparative anatomy and paleoecology and stuff that I don't think I would have got had I just jumped straight into the world of dinosaurs. And it's sort of given me a different way of thinking about questions around dinosaur behavior, locomotion, paleoecology, taphonomy, variation, species concepts, and stuff that crocs are good for helping you understand those things. So anyone out there listening, if you're thinking about doing dinosaurs, maybe give crocs a go first because that'll get you going and put you on the right foot. And
Right.
crocs are funny. Crocs are fun in their own right as well. So you might end up just doing crocs.
And the best part about them is you can go see live ones still today. So,
well, yeah, I mean, and I can hear a dinosaur cooing behind me, so there's still dinosaurs around, but yeah,
they're not as cool looking as they were in the past. So
they look a bit different to the extinct ones.
Yeah.
All right.
Thanks for coming on.
No worries. Giving you plenty of stuff to work with there. If anyone's listened to the end, thanks for listening. Hopefully there was something in there for people. I'm glad. I'm glad you're interested in crocs and the bigger picture. There's a lot of great research. There's a lot of really important questions that are being asked, and crocs are a fantastic way to get into it.
All right.
Amazing animals.
Yeah. Well, thanks for coming on the show.
No worries. Thank you. Good night. See ya.